By facilitating proper water drainage and decreasing road erosion, well-maintained roadside ditches and surface cross drains protect both the road and the environment. In this program, we're going to take a look at the primary methods of effectively maintaining these crucial systems.
In your routine maintenance of roadside ditches with a grader, you have two primary options. You can heel the ditch, which stores waste against the cut slope until enough accumulates to warrant removal, or you can pull the ditch, removing the accumulated material and redefining the shape of the structure.
Regardless of the method used, it's always important to carefully consider the work you're planning to do. Remember, as long as a ditch is functioning properly, there may be no need to take any corrective action at all. Small rocks and vegetation can keep the soil in the ditch from eroding, and even larger amounts of debris won't necessarily block water flow. So only work the areas that need it, and always use a light touch.
Once the decision has been made to go ahead with ditch maintenance, scout the area and plan the job. Begin by checking the ditch for riprap or ditch dams. If these devices are to be left in place during maintenance, you'll need to know where they are so you can clean around them. Also, identify all potential obstacles, such as culvert inlets, underdrains, or lead-out ditches, and keep them in mind so that you might avoid damaging them. If the job requires pulling the ditch, determine what will be done with the material after it's removed, and make sure that the ground is firm enough to support heavy machinery. Finally, put up the proper traffic control devices and safety signs, and you're ready to begin the job. Heeling is a temporary clearing method that's both quicker and less expensive than pulling, and it can be used on specific trouble spots or for the entire length of the ditch. Heeling usually involves only one pass with a grader. As you move forward, keep the heel of the moldboard extended into the ditch. This will form a small berm of debris against the cut slope. As long as the berm doesn't impede the flow of water through the ditch, it can actually be beneficial. It can slow or stop loose rocks from falling down the cut slope onto the traveled way. When you've completed the pass with the grader, go back over the area with hand tools and clean any culverts, lead-out ditches, or drain pipes. You're then ready to replace any riprap or ditch dams you've removed. Inspect your work and remove your traffic control devices and safety signs. Remember that heeling is only a temporary solution. When the stored ditch material interferes with drainage, it must be removed. Pulling the ditch involves the actual removal of accumulated soil and debris. This procedure is performed lightly and selectively, removing only waste material needed to restore the original ditch template. Position the toe of the moldboard over the portion of the ditch furthest from the road, with the tip touching the bottom of the ditch at the flow line. Rest the moldboard cutting edge lightly on the side of the ditch closest to the roadway. As the grader moves forward, the toe of the moldboard should follow along the flow line to capture mud, silt, and other accumulated materials. The cut should only be deep enough to restore a smooth flow line and make the ditch bottom uniform, allowing water to flow easily along the ditch bottom. As you work, avoid blading aggregate surfacing into the ditch. It's also important not to disturb the cut slope. Undercutting the toe of the slope will result in future slope failure. As you work, the pulled material should roll smoothly off the moldboard and away from the flow line, forming a windrow on the shoulder of the road. As the berm forms, move the material onto the shoulder of the road. If necessary, perform additional passes with the grader. Avoid spreading ditch waste onto aggregate surfaced roads. On native surfaced roads, accumulated ditch material can sometimes be used as surfacing. When you've finished cleaning the ditch, use hand tools to clean any culvert inlets, lead-out ditches, or drain pipes. You're now ready to remove the accumulated debris from this section of the road shoulder, usually with a loader and a dump truck. When you're working with a partner on the ground, be sure you know where that person is at all times. When loading into a dump truck, position the truck uphill from the loader. This will provide greater stability while loading. All collected debris must be taken to an approved disposal site. As with the wrap-up of a healing operation, replace any riprap or ditch dams you've removed. Check your work and remove your traffic control devices and safety signs. Cross drains serve as safety valves to divert water from ruts or wheel tracks that may occur in some situations. Cross drains also help minimize sediment delivery to streams. Whether they're constructed by installing a drainage structure or simply by shaping the traveled way, they must be durable and fully functional. Maintenance involves cleaning them on a regular basis and keeping them free of excessive debris. As wear occurs, they may need to be rebuilt.
In the remainder of the program, we'll discuss rolling drain dips, interceptor dips, and earthen water bars and how to construct them. We'll also look at open-top drainage devices.
The location, spacing, and quantity of cross drains depends on road grade, drainage patterns, soil type, and other factors. If erosion is occurring between cross drains, you may need to construct additional ones.
The number of cross drains should always be sufficient to get water off the traveled way before it gains enough volume and velocity to cause erosion. Also, remember as you're planning a job, avoid constructing surface cross drain outlets on erodible soil wherever possible. And where it's not possible, armor the soil with vegetation or riprap.
Rolling dips capture and divert water off the traveled way through a gradual dip, followed by a bump constructed in the road surface. Rolling drain dips run perpendicular across the traveled way. Of all the earthen cross drain varieties, rolling drain dips require the most time, skill, and money to construct. After planning the work and erecting your traffic control devices and safety signs, begin by removing and temporarily storing any aggregate surfacing from the rolling drain dip location. Scarifying may be needed. Begin cutting downhill, starting at the outlet of the dip where the maximum cut will be made. Raise your mold board to a shallower depth as you move to the inlet side of the dip. Roll the accumulated material into a bump and deposit it on the downgrade side. Multiple passes may be needed. The depth and width of the cut will vary according to the steepness of the road. Compact the soil bump with the greater tire. When you've finished construction, replace the aggregate surfacing you removed earlier. If the rolling drain dip outlets onto erodible soils, protect the ground with riprap or vegetation. Finally, check your work and remove your traffic control devices and safety signs. Like rolling drain dips, interceptor dips divert water off the road by means of an indentation and bump in the traveled way. Unlike rolling drain dips, interceptors are skewed at an angle of 30 to 60 degrees across the traveled way. Interceptor dips are shallow when compared to rolling drain dips. The depth of the cut and the height of the resulting bump are each about 4 inches. The total width of the dip and bump combined is approximately 12 inches. Interceptor dips work well on steeper road grades. The length and angle of interceptors can be varied to effectively capture and divert water from the steepest road grade. When constructing an interceptor dip, The depth of cut is so shallow that it's not necessary to remove the aggregate surfacing from the work area. Position the mold board adjacent to the ditch and make a cut no deeper than 4 inches. As you proceed, cut the dip at approximately a 30-degree angle to the road center line. Then pick up the mold board and back up the grader. Reposition the mold board until the toe is in position to resume cutting, and continue cutting until the dip is completed. As you work, the resulting small berm is placed downhill from the dip and is rolled and compacted with the grader's tires. If the dip outlets onto erodible soils, protect the ground with riprap. Now you're ready to remove your control and safety devices. Earth and water bars provide very poor driver comfort and are drivable only by high clearance vehicles. Therefore, install them only in areas with little or no traffic. Water bars extend across the full width of the road and are skewed up to 30 degrees from a line perpendicular to the center line. They normally require little maintenance. Constructing a water bar requires cutting down about 6 to 12 inches into the traveled way. Deposit the material on the downslope side of the cut. Carefully compact the excavated material. The resulting bump should be about 12 to 18 inches in height and about 2 to 3 feet wide. Erodible ground in the outlet area needs to be protected and any removed road surface aggregate replaced. After completing the water bar, test it to see if it is drivable without scraping the vehicle undercarriage. Open-top drainage devices are pipes with sections removed, buried across the width of the road. Like the other cross drains we've reviewed, they capture water and funnel it off the traveled way into a protected area. These are high-maintenance devices that need to be cleaned regularly to remain effective. If they're damaged but repairable, they should be fixed.
Poor water drainage is a road's worst enemy. It's also one of the worst enemies of a road's natural surroundings. The procedures and devices we've been reviewing are designed to function together with the road surface to ensure the safe dispersal of water into the environment, minimizing soil erosion and stream sedimentation. The failure of any part of this drainage system impacts all the others. By being informed and conscientious in your upkeep of these essential structures,
Disturbing the soil only when necessary, and then using a light touch, you preserve the road's integrity and protect driver safety and the health of the forest environment.